So here is the summary of general solutions of all the types of trigonometric equations that we have seen so far. In the first type we have the three ratios equal to 0 and their respective general solution. In the second type, the three ratios are non-zero quantities and their general solutions are also tabulated here. So let's take a moment to look at all the general solutions. Moving on, we have the third type and fourth type. In third type we have all the square quantities and all of the equations have the same general solution, that is theta is equal to n pi plus or minus alpha. And the fourth type is a cos theta plus b sin theta equal to c, where c has to be numerically less than root of a square plus b square. So its general solution is also given. And just to recollect, if c is not less than or equal to root of a square plus b square, then the solution does not exist. Now based on this, let us solve some miscellaneous examples of finding the general solutions. In that, the first one is sin 2x plus sin 4x plus sin 6x equal to 0. Now here it's clear that somewhere we have to club two sine terms so that we can reduce the number of terms. But the question is which two terms we should combine. So if we look at the numbers, that is 2, 4 and 6, and looking at the formulae of factorization, we see that it will be easier if we club sin 2x and sin 6x, because in that one of the angle in the factorization will be 4x, so that the term sin 4x can be taken common, right? So therefore let us rewrite the equation as sin 6x plus sin 2x, which we do first, and then we have plus sin 4x equal to 0. So therefore factorizing, we have 2 sin of 6x plus 2x upon 2, that is 2 sin of a plus b by 2 into cos of a minus b upon 2, right, plus sin 4x as it is equal to 0. Therefore we can cancel out the factor of 2, and clubbing we get 6 plus 2, 8 upon 2, that is 4. So sin 4x cos of 2x plus sin 4x is equal to 0. Now we can take sin 4x common from both sides, so that gives us sin 4x into bracket 2 cos 2x plus 1 is equal to 0. So therefore sin 4x is equal to 0, or 2 cos 2x plus 1 is equal to 0. That is, here it means cos of 2x is equal to minus 1 by 2. Now if you consider the first equation, that is sin 4x is equal to 0, then we can write the general solution as 4x to be equal to n pi. So therefore x is equal to n pi by 4. This is first possibility. Or second possibility is, if you remember, it is cos 2x equal to cos alpha type of equation. So here we have to write down it is cos of which angle. So since cos is negative, it has to be some angle in the the second quadrant, and that is nothing but 120 degrees, which is 2 pi by 3. So cos 2x equal to cos 2 pi by 3. So therefore we have 2x is equal to 2 m pi. So here instead of n we take m as a different counter just to make it clearer, plus or minus 2 pi by 3. So therefore we can cancel out a factor of 2 and say that x is equal to m pi plus or minus pi by 3. And in both of these, m and n are the integers. So therefore we have the general solution given by x equal to n pi by 4 or x equal to m pi plus or minus pi by 3. Let's go over to the next question. Now here the equation given is sec square 2x is equal to 1 minus tan 2x. Now here apparently it does not seem to be of any type that we have seen so far, but looking at the terms given we can easily guess that sec square can be written as tan square plus 1, because by doing that 1 will get cancelled from both sides, and let's bring the tan term on the left side. So therefore we get tan square 2x plus tan 2x is equal to 0. So taking tan 2x common, we have tan 2x plus 1 equal to 0. So that gives us tan 2x is equal to 0 or tan 2x is equal to minus 1. Now tan 2x equal to 0 gives us the general solution as 2x is equal to n pi, which means x is equal to n pi by 2, right? That's the first possibility. Or the second possibility is, since tan 2x is minus 1, we can write minus 1 as tan of 3 pi by 4, which is 135 degrees in the second quadrant. Right? So we have tan 2x equal to tan 3 pi by 4. So therefore its general solution is given by 2x is equal to, instead of n, now we consider m pi plus 3 pi by 4, which is a general solution of the type of equation tan theta equal to tan alpha, right? As we want x, we will cancel the factor of 2 from both sides, giving us x equal to m pi by 2 plus 3 pi by 8. Right. So therefore these are the general solutions given that m and n are integers. So it is either n pi by 2 or m pi by 2 plus 3 pi by 8. Let's see one more. Now here the equation given is sin x tan x equal to tan x minus sin x plus 1. Now once again, this also does not seem to be of any of the standard types. But if we transfer all the terms on one side, let us see what happens. We get sin x tan x minus tan x plus sin x minus 1 equal to 0. So therefore we can immediately recognize that from the first two terms we can take tan x common, giving sin x minus 1 in the bracket, plus we already have sin x minus 1 as the remaining two terms. Right? So therefore this was actually the example of factorization. So we have the two factors as sin x minus 1 and tan x plus 1 equal to 0. So as each factor has to be 0, that gives us, we can write directly sin x has to be equal to 1 or tan x has to be equal to minus 1. That means sin x equal to, we can write 1 as sine of pi by 2, which is a known angle, or tan x equal to, and here we can write minus 1 as tan of 3 pi by 4. So therefore writing the general solution of the first, we have x is equal to n pi plus minus 1 raised to n times pi by 2, right? That's the general solution of the first part. Or second possibility is, here x is equal to m pi plus 3 pi by 4, which is the second possibility, where m and n are integers. So these are the required general solutions of the given equation.